All right, let's do some Descartes rule of signs examples. Now I'm going to be working on Algebra 2 homework 7.3, but I'm going to be working only the problems that deal with Descartes rule of signs, and I kind of am recording these as a separate video because not all of the sections of Algebra 2 are learning about Descartes rule of signs, but if you're in my section, then you learned about it and you're going to want to do these practice problems as well, because it's good algebra. So, how many positive zeros does the polynomial x to the 4 minus x squared minus 6 have? Justify my answer. Okay, well I got to count the sign changes. That's what I've got. I'm going to be like real explicit with this first one. I've got positive 1 x to the 4 minus 1 x to the 2 minus 6. Okay? And I went from positive to negative to negative. And that's one sign change on f of x, right? Okay. So if we're looking for positive zeros, we're analyzing f of positive x, just like the polynomial as it comes. Positive zeros on f of x. Okay, so if there's one sign change, that means there's exactly one positive zero. Positive root, I guess is probably a better terminology there. But I would say one positive root. Okay, it can always be the number of sign changes or less by an even number, less by a multiple of 2. And we know that the reason why it's a multiple of 2 is because those complex root or those imaginary roots come in conjugate pairs. How many negative zeros does this next polynomial have? Justify our answer. Okay, well, we'll find out. So what we're going to do is we're going to say, right, if f of x equals x to the 3 minus 4x to the 2 plus 8x plus 7, and we're considering the number of negative roots, we're going to have to plug in f of negative x. Okay. So, and we're going to do that by just replacing x with negative x in parentheses everywhere we see it in the formula. Okay, so x to the 3, okay, we're taking negative x cubed, minus 4 times x squared, well, we're replacing that x with a negative x. This x gets replaced with a negative x, but 7 doesn't have an x on it, so it's just going to stay 7. Okay, and then we simplify, remembering that like we're going to look at all of these, and I guess since the first time I'm doing it in the examples video, I'm going to just distribute the positive 8 to the negative x and then do a plus 7. Okay, but it's the taking to the third power and taking to the second power that's like the subtlety here. Okay, so what you need to remember is that if I'm taking, negative 1 times x to the third power, that's like taking negative 1 to the third times x to the third. And negative 1 to the third is going to be negative 1 because an odd number of negatives makes negative. So this is negative x to the third. And same thing over here, if I'm taking negative 1 times x and I'm squaring it, then I've got 2 copies of negative 1 and 2 copies of x. Okay, and so that's going to be negative 1 times negative 1 is positive x squared. Okay, and now I've got f of negative x, and my signs went negative, 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 positive. Okay, that's also just one sign change. So that means one negative root. On f of negative x, which is what I have to consider to do Descartes rule of signs to determine the number of negative roots. Okay, so that means one negative root. All right, now the next few are going to ask you to explain why each of the following classifications aren't possible for the zeros of this polynomial. And so I think what I'm going to do is, like, I left this space right here for you to do the Descartes rule of signs analysis and, kind of list out the possibilities. And then after we've listed out the possibilities, it'll be easier for us to look at the problems and be like, okay, what's wrong here? So I'm going to investigate for my positive roots. I'm going to investigate f of positive x. Okay, it's the polynomial as it came to us. So that's positive x to the 5 minus 4x to the 3, that's a sign change, plus 6x squared, that's another one, plus 2x minus 6. So I've seen change signs a couple of times here. I went from positive to negative, negative to positive. Okay, I went positive twice. Okay, but then positive to negative, that's 3 sign changes. So that means, for positive roots, I've got either 3 or 1. It can be fewer by a multiple of 2. Okay, for negative roots, just need to consider f of negative x. And so that's going to be taking negative x to the 5th power minus 4 times negative x taken to the 3rd power plus 6 of negative x squared plus 2 times negative x minus 6. Okay, so if I take negative x to the 5th power, it's going to be 5 powers of negative 1. It's going to be negative x to the 5th. Negative 4 times negative x cubed, okay, again an odd number of negatives makes negative x cubed. Negative x cubed times negative 4 would be positive 4x to the 3. Okay, negative x, if I square that, that's an even number. Okay, that's going to keep the same sign. Okay, negative 2x minus 6. So I've got 2 sign changes. Yeah. So if I've got 2 sign changes on f of negative x, that means I have 2 or potentially 0 negative roots. Okay, so then I can go kind of off to the side and make a table of all the possibilities. Oops, pardon me. So I can have positive, negative, and imaginary. All right, so, I can have 3 positive roots. That's a possibility. And then it's a fifth degree polynomial, so all of these rows of possibilities are going to have to add up to 5. Okay, with with negative, we saw that there was either 2 or 0. So both of these seem possible. Now, if we had 3 positive and 2 negative, we wouldn't have any room for any imaginary because it's only a fifth degree polynomial. And so we'd have no imaginary roots. If it was 3 and 0, then there would be 2 imaginary roots. And then I guess there's also the possibility that there was 1 positive root. And then that would be, we could have 2 or 0 negative roots. And we just kind of fill out the imaginaries from there. 1 plus 2 is 3, so I'd need 2 imaginary. And if there was only 1 positive root, only 1 real root, there would need to be 4 imaginary roots. Okay. So this table off to the side that I've made should have enough information to tell us why 5 and 6 and 7 and 8 must be false. Okay, so 3 positive zeros, 1 negative 0, and 2 imaginary. Okay, well that would be a total of 6, and it's a fifth degree polynomial. I think that's probably the plainest reason with the fundamental theorem. Okay. So we can only have up to 5. We can only have 5 roots, pardon me. Okay, 3 positive zeros, 1 negative 0, and 1 imaginary. So that adds up to 5, 3, 1, and 1. Okay, well there were 2 sign changes in f of negative x. Okay, and that means that there were either 2 or 0 negative roots, but 1 negative root's not an option. That's the Descartes rule of signs. Okay, 2 positive, 1 negative, and 2 imaginary. Okay, that would add up to 5. But again, kind of Descartes rule of signs, there was 3 sign changes in f of regular x. So we can't have 2, right? Or also, you could say the same thing. There are 2 sign changes in f of negative x, so I can't have 1 negative 0. Yeah, oops. 1 negative root. I thought there was one on here that said, like, I don't know, something with 1 imaginary root. Maybe I put that on like the old quiz or something. I remember that from when we did college algebra because they come in conjugate pairs, but okay, that's too bad. Okay, 1 positive, that's possible. 2 negative, and 2 imaginary. 1 positive, 2 negative, 2 imaginary. Feeling like that is possible. Let me think about that. Yeah, I must have like typed that in wrong or something, but maybe it was a trick question. But this is possible. That'll be all for that problem. All right, so this one is true, false, or maybe. Explain your reasoning. All right, so we're just going to do the Descartes rule of signs analysis off to the side. So for positive roots, we've got f of x having 1, 2 sign changes. Okay. So that means we have either 2 or 0 positive roots. Okay. For negative roots, I'm going to write f of negative x. Okay, so I'm going to have negative x taken to the 5th power minus 2 times negative x taken to the 3rd power minus negative x squared and a positive 6. That's still visible to you, so I've got negative x to the 5. Negative 2 times negative x cubed would be positive 2x cubed minus positive x squared and plus 6. It's got 1, 2, 3 sign changes. So that means 3 or 1 negative roots. Right, so f has 2 negative roots. No, that's definitely false. Our options are 3 or 1. Okay. F has 4 imaginary roots. That could be potentially true, definitely not guaranteed true, but that could happen if 0 positive and 1 negative. One positive root, no positive roots like here, and 1 negative root like that. If both of those were the case, then we would have 4 imaginary roots. Yeah, because there'd be 5 total. Okay, f has at least 1 negative root. Yes, that must be true because my options are 3 or 1. F has no imaginary roots. Yeah, that could be possible if I had this 2 and that 3, right? So maybe, not a guarantee, if 2 positive and 3 negative. Okay, and that's going to be all for this video. Descartes rule of signs, it's not something that we're going to use extensively in this class, but I think it's good algebra, and it's just one of a number of tools we can use to analyze polynomials, and I think it's right at y'all's level, and so I thought it was something good to add to our class. Thanks for watching.